So for chapter 6, we started the chapter with exponent rules. There were a couple of different exponent rules that we did. We did multiplying, dividing, and then we also did with this power to a power, but we also just simplified. So when we had the exponents, when to simplify this one right here, the only thing that you would need to do is you can't have a negative exponent, so you'd have to move it. So all of these, you're going to imagine like they're written as fractions. And if it has a positive exponent, it stays where it's at. If it has a negative exponent, you put it in the denominator. So the 8 and the d cubed stay put. C to the negative fourth, when I put it in the denominator, it becomes c to the positive fourth. And that's all you would do. So simplifying doesn't always mean you're going to be actually doing some math. You may just be moving some things around. For part B here, you are multiplying. So when you multiply, which we did do in chapter 7, which is coming up here in a second, we're going to multiply the numbers out front. 2 times negative 5 is negative 10. And then when you multiply your variables, what do you do with their exponents? Add them. This has an exponent of 1. 3 plus 1, x to the fourth. All of your exponents are positive, so you leave it like that. That's it. For C, the 8, you're multiplying again, so we're going to be adding some exponents. 8 has nothing to multiply with, so we have 8. X to the 7th and x to the 1st, you add those exponents and you get x to the 6th, because 7 plus negative 1 is 6. And then y cubed times y to the negative 3rd times y to the negative 2nd. Add those, you get y to the negative 5th. But you cannot leave it as a negative exponent, so you have to simplify it further. The 8 and the x to the 6th can stay put. Y to the negative 5th, you need to put in the denominator. So whenever you have a negative exponent, you have to move it. That's it for those. So there's all your multiplication. Then we got to division. So when you divide your numbers. 12 divided by 4 is 3. And then x to the 7th over x to the 12th. What do we do with our exponents when we are dividing? Subtract them. 7 minus 12 is negative 5. But again, you cannot have negative exponents. So you leave the 3 alone. The x is the only thing with a negative exponent, so it switches spots and it becomes x to the 5th on the bottom. So negative exponents, you need to reduce them, or simplify them, I guess I should say, make them positive, put them in the denominator. For part E, we've got a decent amount of stuff going on here, but you just take it little bit by bit. 24 divided by 6 is 4. A to the 8th over a to the 5th. Divide them, which means you subtract their exponents. 8 minus 5 is 3. And then b cubed over b cubed becomes b to the 0, which means it goes away. No negative exponents, so you're done. So that one was kind of easy. And then for F, this is the, yes, go ahead, sorry.
Oh, why is D a fraction? Why can it not just be 3x?
Because this is 3x to the negative 5, and you can't have negative exponents.
Oh, I see.
Because 7 minus 12 is a negative 5. Okay. And then for F, we have 3x to the 7th being raised to the 4th, and the 4 is on the outside. So that means that you're going to distribute the exponent. So we were going to have 3 to the 4th, which we're going to have to figure out what that is. When you distribute an exponent to an exponent, when you distribute, what operation do you use? Multiplication. So if we're distributing an exponent to another exponent, you multiply those exponents and you get 7 times 4, x to the 28th. 3 to the 4th, though, you've got to figure out what that is, and that's where your calculator is going to help. So you're going to plug in 3, and then you're going to press that caret key to the 4th. It's 3 times 3 times 3 times 3, which is 81. So it's 81 x to the 28th. And there's some of your exponent rules. You guys did pretty good with the exponent rules when we did them at first. Any questions on those? Okay, 2 and 3 are you're like moving in between radicals and rational exponents. These ones you guys did pretty good on. It's just been a while since we've really done anything with them because there's really not much more to do with them in this course. So when I give you a radical here, this is called a radical because it has this root. When you rewrite this, you take the 4, leave it alone, and then you're going to write this as a fraction. The exponent that's with the 4 goes on top. The root, or whatever's in the little crevice here, that goes on the bottom. So this is how you would write it.
I remember this one.
Do you remember this?
Yeah, not that far.
And then for number 3, you're going backwards. So I give you the number raised to the exponent, and I want you to write it as a radical. So we write our radical, put the 5 on the outside, good. On the inside, you have the 8, and the 8 is raised to the 3rd power.
That's not on the test.
No, this is chapter 6. This is on your exam, though. Okay, any questions there? All right. Next thing are these graphs. These graphs are going to be kind of hard to do on an exam because it's got to be multiple choice. So what probably will happen is we'll give you an equation here, and we'll have 4 different graphs.
Can I have a copy of
Another quiz. I don't need any more. So if I give you, what's going to happen, like I said, is there's going to be, oh my goodness. All right. We're going to give you an equation, and they're going to show you 4 different graphs, and you're going to have to identify which graph goes where. What I would recommend doing is if they give you an equation, I would make a table. I can't stress that enough. It's not going to tell you to make a table, but I would make a table so that you can check and see what the graph should look like. And that's where your calculator is going to help you. So we're going to take these numbers right here and plug them in for the exponent. So we do 2 parentheses, 3 parentheses, and then that caret key, don't forget that right underneath the clear, carry it to the -2 power, and you get 0.2 repeating. Second enter, instead of a -2, I want to plug in a -1, and now I have 0.6 repeating. Second enter, instead of a -1, I want to plug in a 0, and I get a 2. Second enter, instead of a 0, I want to plug in a 1, I get a 6. Second enter, instead of a 1, I want to plug in a 2, and I get an 18. These are exponentials, so they're going to either increase steadily or decrease steadily. And exponentials were on your last test that we did. You had to write the equations, the a, b to the x. Those are back right here. So when we go to plot this, we have -2, that's about 0.2 repeating right there. -1, a little over halfway. 0, 2, 1, 6, and then 2, 18 would be way up there somewhere. So this is what the graphs would look like. And remember, they get really, really close to the x-axis, but they never, ever touch it. So it's called an asymptote. All right, so this is what your graph looks like. Now we need to do all the key characteristics. What would the domain be? -infinity to +infinity. Range. How low does it go? It gets close to 0, comma. How high does it go? Infinity. Good. Not worried about the brackets too much. What is the y-intercept? 2. The horizontal asymptote. So the line that your graph is getting really, really close to but is never touching. It's going to be y equals 0. That's the x-axis is y equals 0. I know it's weird. So it's the x-axis. And then is your graph increasing or decreasing? Is your graph here going up or down? Increasing. From left to right, it's going up, so it's increasing. And that's all you would have to do for these exponential graphs. There's no increasing intervals or decreasing like with the other ones, which is kind of nice. You're going to ask how many of these?
Yeah.
I don't know. 1 or 2. There's 58 total questions on your exam.
That's it?
Yep. Okay, number 5. taking a look at these ones, and we have to figure out if they're linear or exponential. That's it. Linear functions are when they use addition or subtraction for the pattern of your y's. Exponential is when they use multiplication for the pattern of your y's. So looking at A and looking at our y values here, are we using addition or subtraction, or are we using multiplication to get from one number to the next? We are subtracting what each time? Subtracting 3 each time. So this would be linear, and the reason why is because you are subtracting 3. That's your explain. What about B? What are we doing each time here? What are we doing? Timesing by 3 or multiplying by 3. So this would be exponential. And the reasoning is that you are multiplying by 3 each time. Any questions? Okay, next page. Story problems. Okay, first scenario. It says, suppose a population of a town is 3,500 and is growing 4% each year. Predict the population after 2 years. So all of your exponential equations have to be of the form y equals a times b to the x. That's what your exponential equations will always look like. If you have growth, your b is going to be 1 plus the rate. We had this written up on the board off to the right for a while. If it's decay, your b is 1 minus the rate. So you've got to make sure you know what the actual rate is, and we've got to do something with that rate, and we're either going to add or subtract it from 1. So if we take a look at this first scenario here, we have a population of a town that's 3,500 and it's growing. So the fact that it's growing means that we have exponential growth. So we're going to have to end up doing this right here. So first thing they want us to do is identify A. So in this case, what is our A value? 3,500. A is always the initial value. It's your starting value. So A is 3,500. That's what we're starting with. And it's growing. So hopefully when it's all said and done, the prediction, it has to be bigger than that. What is our rate? 4%. But when we plug this in to our equation, how do I plug 4% in? 0.04. Good. The decimal is right here, and you move it 2 places to the left, and you end up getting 0.04. You cannot use just 4% in your problem. You have to actually convert it to 0.04. Then, now that we know that's what the R is, and we know that this is growth, now we need to figure out what are we actually plugging in for B. 1 plus 0.04, or you could put, because 1 plus 0.04 is 1.04. Either one of these would be fine. Now that you have your A value, and now that you have your B value, you can write your equation. So our equation is y equals A, so 3,500. Please stop talking. 3,500, parentheses, B, and you can choose either one of these to plug in, to the x power. If you want to put 1 plus 0.04, that's totally fine. It's your equation. I'm probably not even going to look at equations. I'm going to be looking to make sure you know how to predict the value. Yeah. What 2? Right now, we're going to use the 2 right here, because now we're going to use our equation to predict what the population would be after 2 years. So now we're going to take that 2 and we're going to plug it in for x. And that's where your calculator is going to come in. Notice we haven't even used a calculator yet. So we're going to plug in 3,500, parentheses, 1.04 raised to the second power. So after 2 years, we would expect to have a population of 3,785.6. Obviously it's people, so you wouldn't have 0.6 persons, but get the point. Any questions there? Okay, let's take a look at a decay. So it says a boat costs $25,000 and decreases in value by 8% per year. How much will the boat be worth after 5 years? So what is the A value? 25,000. That's what we're starting with. What is the R? 8%. But when we plug this into our equation, how do we plug it in? 0.08. Knowing how to convert is going to be huge because that's what you're actually going to be plugging in. Then it wants to know what is the B value. So is this exponential growth or decay? Decay. So how do we find our B value? 1 minus the 0.08. What is 1 minus 0.08? 0.92. So you can plug either one of these in. Okay? Doesn't matter. You can either plug in 1 minus 0.08, or you can actually do 1 minus 0.08 and get 0.92. It's the same thing. Then they want you to write the equation. So we have y equals A, which we set up above was 25,000, not 100. It'd be a cheap boat. Parentheses, times B. So you can write either one. I'm just going to write 0.92 because it's to the x power. So that's our equation, but they want to know now what can we predict that the boat would cost or be worth after 5 years. So now you're going to plug 5 in. That's where your calculator comes into play. So we're going to do 25,000 parentheses 0.92 raised to the 5th power. All right, so our boat is worth $16,477.04.
Like in real life.
I think they actually decrease even more than that, faster than that. I think I'd be pretty impressed if it was still worth that much after 5 years. Sadly. Car values just decrease so fast right now. Cars and boats. Okay, any questions there? All right, last thing from chapter 6 is if something is geometric. Does anyone remember what it means for a sequence to be geometric?
Doesn't it mean like it goes in the same order and doesn't like change?
It goes by the same order, but there's a certain pattern it has to be.
I have no clue.
Multiplication. So geometric is just like exponential, where the pattern, which the pattern is the common ratio here, the pattern must be multiplication. So it's either basically going to be a yes or a no. Is it geometric, yes or no? So for A, is this geometric? What's the pattern? Timesing by 3. For B, is this geometric? No, this one's pattern is subtracting 12 each time. That's arithmetic, but we're not dealing with that right now. And then for C, what's going on here? This is geometric. You're multiplying by 1. You're dividing by 2, which means you are multiplying by 1/2. Yes.